Remember when you were a kid and you didn't want to go home, but it was getting dark and your mother was calling you? Have you ever wanted to see the white nights of the northern latitudes, but don't live someplace like St. Petersburg, Russia? Well, very soon it will be possible to say goodbye to the darkness of night, and we might only know the beginning of a new day by looking at a clock. This is all because scientists have created an artificial sun. But first things first. Over the past 200 years, the quality of life for most people in the world has increased dramatically. The discovery of electricity helped propel humanity deeper into the industrial age, and now into the era of information. Today, billions of people have continuous access to telephones, computers, environmentally friendly cars, and other incredibly convenient technologies that work with electricity. But the electricity we use is produced from a variety of different sources. Some of them are renewable, like wind, solar, or water power. But most electricity is still produced by burning some kind of fuel. According to the latest data from this variety of sources from around the world, the total amount of energy produced per year is an incredible 155,481 terawatt hours. Different sources have different efficiency and are differently transformed into electricity, so it's perhaps better to look at the energy that households, industries, and businesses consume, which composes about 70% of the total. It turns out that just to ensure our normal way of life, we need to generate about 5.6 times 10 to the 20th power joules of energy per year. One of the oldest methods of producing energy is by burning coal, and due to the compactness of this material and the simplicity of the process, it's in use almost everywhere. But the power-generating advantage of coal is tarnished by its disadvantages. In order to fully meet the planet's energy needs, it would be necessary to burn up to 8 billion tons of the material every year. And coal, in addition to giving us plentiful energy, also strongly pollutes the atmosphere. Then there's oil. If coal is a symbol of the 18th and 19th centuries, then oil is the symbol of energy for the 20th century and is still the main source of energy on the planet. It's estimated that if the world depended entirely on this so-called black gold, we would have to burn more than 12 billion tons of the stuff a year, with all of its associated negative effects. And by the end of the 20th century, people began to really seriously focus on environmental pollution caused by burning such things as coal and oil. A solution was found in the form of natural gas. This fuel already produces more than 20% of mankind's energy needs. Natural gas contains fewer toxic substances than coal or oil, and its efficiency when burnt is an order of magnitude higher. But when it's burned, carbon dioxide is still produced, which many believe causes harm to the atmosphere by advancing global warming. Therefore, scientists have had to look further with a view towards developing renewable energy sources. And if dams and windmills cost too much and can only be installed in certain places, then at least the alternative solar energy should be able to be produced almost anywhere, if only there were no clouds. Recently, German scientists announced the creation of a carbon-neutral fuel capable of creating a temperature of up to 3,700 degrees Celsius. In other words, they created an artificial sun. The Sunlight project consists of 149 xenon arc lamps that emit a light 10,000 times brighter than the natural sunlight we normally receive here at the Earth's surface. Basically, if all of the lamps are focused in one direction and the light is then concentrated on one particular spot, the temperature will quickly rise. By the way, a person who would dare walk under such a light would instantly burst into flames. So that the experiment won't harm people, it's being conducted in a special sealed laboratory. But if you think that this is just a really cool and amusing experiment, then you are deeply mistaken. Its real purpose is to try to attain the necessary concentration of light to start a reaction that could create hydrogen, potentially the most efficient and clean-burning source of energy there is. You might know that conventional solar power plants use mirrors to focus sunlight on a container of water. After a while, the water temperature rises and the container begins to emit steam, which is then utilized to drive turbines to generate electricity. The Sunlight artificial sun works using the same technology, only its action is aimed at obtaining pure hydrogen from the steam, which would then be used as fuel for airplanes and cars and the like. The main problem with the Synlight is its low efficiency. Over the course of just 4 hours of operation, this contraption uses about the same amount of energy as 4 people consume over an entire year. Of course, the scientists working on the project insist they will increase its efficiency in the near future. So at this point, illuminating a city using such an artificial sun is not economically feasible. Speaking of illuminating villages, the inhabitants of the Italian village of Viganella, which is located in a valley between some mountains, did something very interesting to solve their problem of a lack of sunlight. Every February, the sun would cease illuminating their village entirely for a number of months. So they made some simple calculations and then installed a gigantic mirror on a nearby mountainside that did receive sunlight to reflect it down upon them. The mirror, by the way, is a metal sheet about 40 meters square. And this was enough to make their previously dark and dull Februaries now shine brightly. Incidentally, even if a second sun like the Synlight were put into orbit, its appearance for the majority of humankind would go unnoticed. And no, it's not because people are too lazy to look up. The current level of nighttime illumination from city lights has turned our nights into a kind of protracted twilight. Continuing at this pace, in the not-too-distant future, we'll all end up living in something approximating an eternal light of day. In these modern times, regarding urban street lighting and such, various different systems are used, from ordinary incandescent lamps to devices working with excitable chemical elements such as mercury, neon, xenon, and halogen. So what does a typical modern metropolitan evening look like? All too often these days, the streetlights of our thoroughfares and boulevards are flooded by a yellow-orange light that is irritating to the eyes. And these sodium vapor lamps are not very successful at driving away the darkness either. They cover a very narrow range of the visible light spectrum, and this badly affects color rendition. So if you want to look like an unripe lemon, go ahead, get under one of these things. In most offices, one must endure something like an eternal day. If our courageous white-collar workers happen to glance up, they might notice the long, tubular fluorescent lights hidden away on the ceiling. Such devices are quite popular as they consume relatively little energy. But most people are unaware that these wicked lamps are flickering very quickly, almost imperceptibly to the eye, which is extraordinarily irritating and can cause severe eye strain. Additionally, their fragile glass construction requires very careful handling. If they break, they can seriously damage one's health. Despite their relatively strong performance characteristics, incandescent lights do have 2 significant drawbacks: short lifespan and high energy consumption. As probably everybody knows by now, they are gradually being replaced by a new generation of lighting sources, LED lamps and LED panels. Most experts now agree that the future belongs to this amazing technology. Already, LEDs are being used for such things as illuminating road signs, lighting outdoor advertising, and of course, for a multitude of domestic needs. Unlike incandescent light bulbs, LEDs can be miniaturized, and they are twice or greater as efficient as the previously standard lamps. So, world domination by light-emitting diodes is only a matter of time. And by 2030, they'll have become our main source of lighting. This isn't, however, something we should necessarily celebrate. The problems that are associated with this encroaching total illumination of our world are greater than one might at first expect. Gradually, our planet is being deprived of its nighttime darkness, without which our world's flora and fauna will suffer great damage. It's likely that very soon in developed countries, the need for a dark sky above our heads will outweigh our need for nighttime lighting. Initially, it was assumed that LED lighting would help reduce energy consumption and lessen light pollution. At the local level, these predictions came true, but on a global scale, the relative cheapness of LED technology has allowed people to now illuminate much larger areas and to do this more cheaply. This, in turn, has increased the total brightness of artificial lighting when considering the entire Earth's surface. People are now installing additional light sources everywhere, and it's completely destroying the natural nocturnal world. So in the end, no countries that are converting to LED lighting are reducing light pollution. According to satellite data, the total illuminated area on our planet is increasing by 2% every year. And this is not even taking into account the blue spectrum of radiation from LEDs that the cameras simply cannot see. Yet people are very sensitive to this blue spectrum. A number of studies have shown that constant viewing of blue spectrum light at night disrupts our circadian rhythms, which leads to sleep disorders and other problems with our health. Artificial light also disrupts the system of pollination of plants, as well as threatening the livelihoods of nocturnal animals and birds. Over the course of millions of years of evolution, birds learned to navigate their way through the night with the help of the moon and stars. But now, during the migration season, they have to fly through brightly lit areas, which leads to a devastating loss of orientation. So, what will happen next, you may ask? Forecasts are mixed. Lately, there have been calls for warmer lighting using a less detrimental spectrum of radiation. But we're still very far from full awareness of the problem. A number of specialists have suggested we turn to urban studies. Their ideas generally amount to something like this. As we cannot completely refuse to illuminate our cities, let's change the cities themselves. To reduce the harmful effects of light-emitting diodes to a minimum, they propose to create special day and night lighting landscapes, which will enter into a kind of symbiosis with the natural environment. Another interesting innovation will be the use of lighting on demand. For example, the number of lights on a road will depend on its workload. But for such innovations to be realized, it'll be necessary to radically change the infrastructure of our cities. So, we'll just have to wait to see what happens next. Subscribe to our channel and give us a like if you also want to see the starry sky. Write in the comments, how would you try to save the planet from this lighting Armageddon? Could you give up artificial lighting? And remember, as always, Riddle is with you. Until next time.